Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello students, viewers, subscribers, and future engineers. There is another set of problems in calculus about computing slope of tangents to curves at a point, and the other interpretation of derivative is rate of change. So I'll present the solution in a manner that is ready-made, less animations to shorten the solution, and second, my intention is to reduce the uh, consumption of to reduce the file size so that we can have a smooth flow of discussions here. So find the slope of the curve at a given point. There are 8 exercises here, then another exercise on the right side. So since in the preceding slides I derived using limits the derivative of functions, algebraic functions, basic. So let's apply that in this video. So slope is denoted by m, slope of tangent, and it is the derivative of y with respect to x. So for number 1, the derivative of y with respect to x is the derivative of constant is 0, and this is negative 2x. So dy dx is 0 minus 2x. So m dy dx is negative 2 times x1, and x is 3. Therefore, the slope is negative 6. For problem 2, y is 3x squared minus 2x, and we find the slope at the point 2, 8. x1 is 2, y1 is 8. So m dy dx is equal to 3. Derivative of x squared is 2x. Then minus constant 2. Derivative of x is 1. So negative 2. So therefore, simplifying dy dx is 6x minus 2. So substitute 6 times 2 minus 2 is 10. So the slope of the curve for problem 2 is 10. Then number 3, y is 2x cubed minus 3x at the point negative 1, 1. So dy dx slope 2 times derivative of x cubed 3x squared, 3x to the power 3 minus 1, or 3x squared, then minus 3 times 1, so minus 3. Simplifying 6x squared minus 3. So substitute 6 times negative 6 times negative 1 squared minus 3, so it is equal to 6 minus 3, so 3. Slope of the curve, or slope of tangent to the curve, therefore is 3. Problem 4. This is problem 4. So take note that the if you check the point, these given points lie on the curve by simply substituting values. So for instance, 1 cube is 1 minus 1 square is 1, so 1 minus 1 is 0. 2x cubed, 2 times negative 1 cube, negative 2 minus 3 times negative 1. So negative 2 plus 3 is 1. So you also check the rest. So derivative of x squared minus x cubed is 2x minus 3x squared. So 2 times 1 minus 3 times 1 squared is negative 1. So slope for problem 4 is negative 1. problem 5, y equals 1 over x squared, we can rewrite that at 2 comma 1/4. When x is 2, y is 1/4. We can have the guide derivative of constant over u, and the derivative of constant over u from derivative formulas is negative constant over u squared times derivative of u with respect to x. So in this case, if you imagine that u is x squared and constant is 1, so the derivative of x squared, the derivative of u is 2x, so this is 2x, and we have negative 1 over u, which is x squared quantity squared, times du dx, which is 2x. So it becomes negative 2 over x cubed. If you simplify, negative 2x over x to the fourth, so negative 2 over x cubed. Slope, therefore, which is dy dx, is negative 2 over x cubed, and x1 is 2. So 2 cubed, the result is negative 1/4. You can have an alternate solution, writing that as y equals x to the negative 2 and apply power formula. So for another batch of problem, so this is the, by the way, this is the alternate solution. For problem 5, y equals x to the negative 2, so dy dx is negative 2 by power formula, x to the negative 2 minus 1, so x to the negative 3. Simplifying, that's negative 2 over x cubed, and we'll have the same result, that the slope is negative 1/4, because we have the same answer for derivative of y with respect to x in general. Number 6, y equals 1 over x plus 1, so it's the same guide there. So it is negative 1. Imagine that x plus 1 is u, so negative constant, negative 1 over u square, x plus 1 quantity square, and the derivative of x plus 1 with respect to x is 1. 1 plus 0 is still 1. So simplifying, negative 1 over x plus 1 quantity square, and substituting x is negative 2, so negative 1 over quantity negative 2 plus 1 square. Negative 2 plus 1 is negative 1, then negative 1 square is positive 1, so negative 1 over positive 1 is negative 1. So slope in problem 6 is negative 1. Problem 7, y square equals 4x. This is a parabola open to the right with vertex at the origin. And since when x is 1, y is positive 2, this is the upper branch of the parabola to make it a function. So we write this as y equals plus minus square root of 4x, and we drop the negative sign because the idea is when x is 1, y is positive 2, so that means we only consider the positive root. So y equals 2, square root of 4x is 2 square root of x plus minus supposedly, but I explained that because when x is 1, y is 2, we consider the upper branch of the parabola, that is positive 2 square root of x. So dy dx is constant 2, and the derivative of square root of u is du dx, which is derivative of x1. So 2 constant, copy. Du dx is 1 over 2 square root of x. So that's the guide. So therefore, simplifying, cancel 2, 1 over square root of x. When x is 1, so we have 1 over square root of 1, which is 1. So slope dy dx is 1. Then number 8, same problem, but this time when x is 1, y is negative 2. So that means it is the lower half of the parabola. So y is negative 2 square root of x. So we use the same guide. So negative 2, derivative of square root of x is 1 over 2 square root of x. So negative 2 times 1 over 2 square root of x, cancel 2. So we have negative 1 over square root of x, and x is positive 1 here. So negative 1 over square root of 1 is negative 1. So the slope for curve 8 is negative 1. Then find the slope of the curve at the given point, 9, y square equals 3x plus 1 at 1 comma 2. Again, this is a parabola open to the right. This time the vertex is at negative 1/3. If you transform this to the standard form for those who are familiar with the standard equations of parabola. If not, you just apply point plotting first, but as though as students in civil engineering and those who are already uh, graduating or gone through with calculus, you should be able to compare this with the standard form of equation of parabola. So since when x is 1, y is 2, we again consider the upper branch of the parabola. This one, when x is negative 1/3, of course, 3 times negative 1/3 is negative 1 plus 1, 0, so square root of 0 is 0. So we consider the, because this is open to the right, and by the way, the vertex is negative 1/3 comma 0. This is the vertex. Then we have two problems on rates of change. So y square equals 3x plus 1. So y is square root of 3x plus 1, the positive one. So the guide is derivative of with respect to x of square root of u is the derivative of u with respect to x all over 2 square root of u. So dy dx du dx over 2 square root of u. This is 2 square root of u, and the derivative of 3x plus 1, because that is imagined as u, is 3. So du dx, or dy dx rather, is 3 over 2 square root of 3x plus 1. Substitute the value of x, which is 1, x1. That's square root of 4, which is 2. So 3 over 2 times 2 is 3/4. So the slope is 3/4. Number 10, same, but the point is negative 1/3 comma 0. So y equals 3x plus 1. The derivative is the same. But when x is negative 1/3, this we have square root of 0 here, negative 1 plus 1, and square root of 0 is 0. 3 over 2 times 0 is still 0, and 3 over 0 is undefined. Because 3 over 0 is undefined, the slope is undefined, or it does not exist. It is a vertical line. That's the interpretation. 11. Find how fast A, the circumference, B, the area of a circle increases when the radius increases. So this is rate of change of circumference with respect to radius, represented by derivative of circumference with respect to radius. Circumference of a circle is 2 pi r. So derivative of circumference with respect to r is constant 2 pi, and the derivative of r with respect to r is 1, of course. So therefore the answer is 2 pi, and the unit would be units per unit, because circumference has units of length. So in general, units per, of course, radius has also a unit of length, so per unit. So that's the resulting units. So if the radius is in meter, then it would be meters per meter. That would be the units. Area of a circle is pi r square. So derivative with respect to r is pi, constant. Then derivative of r square with respect to radius r is 2r. Simplifying or rearranging, derivative of area with respect to r, rate of change of area with respect to r, is 2 pi r, and the units would be units of area, square units, unit of radius, unit, so per unit, square units per unit. Then number 12, find how fast the volume, surface area, the diagonal of a cube increases when the length of the edge increases. We will call the length of the edge as E. Volume of cube is E cube, and the derivative of E cube with respect to E is 3E squared by power formula, and the units would be cubic units, because that's volume per edge, which is unit. So du dE, dV dE is derivative of volume with respect to E. Rate of change of volume with respect to the length of the edge is 3E squared cubic units per unit. Total surface area, the cube has 6 faces, and each face of a cube is a square. The area of a square is E square. times 6, so the total surface area is 6e squared. Derivative of surface area with respect to E therefore is constant 6. Derivative of E squared with respect to E is 2E. So that would be 12E square units per unit. Then finally for C, the length of the diagonal of a cube is square root of E cube plus E cube plus E cube. Square root of 3E square. Sorry, square root of E squared plus E squared plus E squared. That would be square root of 3E squared. And square root of 3E squared is E square root of 3, or square root of 3 times E. So the derivative of the diagonal with respect to E is constant square root of 3. So derivative of diagonal with respect to E is square root of 3 units per unit. So that's it for this video.